Okay, section 8. I believe this is the last section, but I could be wrong. I don't remember. Okay, systems of linear equations and quadratics. Look, systems. Now we're talking about more than one at the same time. We've already done this with linears. Now we're comparing linears and quadratics. There are three possible ways to do this. We can have it to where they cross at two same points. They can cross at just the vertex, or they may never cross. Okay, so it is possible to have different answers. It kind of sounds like the same thing, except this one would be different. When we had two linear equations, they could cross and give us, well, one solution. This one was if they were the same line, and this one is if they never crossed, they were parallel. So we kind of have the same sort of thing. Now what we do need to do is we need to graph them. Okay, so what we're going to see here is we're going to see two equations. This one's going to be the quadratic, this one's the linear. So there's two on the next slide, so I'm not going to ask you to do these. When we do the linear, we get the blue line. Okay. When we do the quadratic, we get the red line. And what we're looking for is we're looking for the location where these two things cross and these two things cross. And the object is to name those two locations. So we look at -2, 4 and 0, 2. So that's what we have. The solutions of the system are -2, 4 and 2, 0. Okay. So here are two for you to try. This one's the quadratic, this is the linear, this is the quadratic, this is a linear. I want you to pause it, and I want you to try both of these, and I can show you the answers when you get to class. Hopefully on Monday. No, sorry, whenever this video would be due. I don't remember. Okay, moving on. Okay, using elimination. All right, these are the old methods for systems of equations. We learned how to graph them. We learned how to eliminate one of the variables. We learned how to substitute one of the variables. Okay, so that's what we're going to do. We're first going to eliminate the value of y. We're going to subtract these two equations. So that's going to give us 0. That's going to give us x squared. 28x minus 39 gives us -11x. And then I get -60. So that's step number 1. Get rid of the y value. We can do that because they both have a 1 in front. Now we notice that this can be factored. So this becomes x minus 15 and x plus 4. Okay? It's solve for x. So that means x is equal to 15 or -4. Well, what we're doing is we're looking for the days on which the attendance is the same. So at -4 days, it's the same. No. That doesn't make sense. So the eliminate the impossible solution means to get rid of the -4. Okay? And then this is what x is. So I'm going to plug it into these equations, and I'm going to work it out. Y is equal to 28 times 15 plus 4, and I get 424. And y is equal to -5 squared plus, 15. 39 times 15 plus 64, and lo and behold, I should get the same answer. So what was the day that they had the same? It was day number 15. And what was the attendance at the pool? It was 424. Voila. Okay, moving on. Maybe not. Just kidding. Okay, substitution. Here we're going to take 4 minus x. We're going to plug it in. Okay, so we get 4 minus x is equal to x squared minus 6x plus 10. Notice this one's just a regular problem. So I'm going to move all of this over here. I'm going to get x squared. Nothing's going to happen to that. I'm going to move that. That gives me minus 5x. And I'm going to move that. That's going to give me plus 6. Well, that's factorable. X minus 3, x minus 2. So that gives me x is equal to positive 3 or positive 2. Cha-ching. Those are the answers. Do the same thing down here. Take y, take that, plug it in, work it out. Okay, and I believe these are the practice problems, and we're done. Check the answers when you ask in class. See ya.